Good morning everybody. Last time we have to explain light dependent resistor, that is in symbolically LDR or photoresistor. In LDR or in photoresistor, it is a general purpose photoconductive cell. LDR is a type of semiconductor whose conductivity changes with the intensity of light. At that time, we have to explain principle of LDR. The electrical resistance of LDR decreases to increase the intensity of incident light. Electrical resistance of LDR decreases to increase the intensity of incident light. This is the principle of LDR. LDR is light dependent resistor. This is the full form of LDR, light dependent resistor, or shortly photoresistor, keeping your mind. Student, this is the symbol of LDR. In LDR symbol, we have to use resistor symbol, that is in this way. Now I am going to start application of LDR. Light dependent resistors are simple and low cost devices. These resistors are used as a light sensor. Resistors are used in the light sensor. Number 2, it is used in the clocks, street light, automatic light signal. LDR is used in intensity meters, burglar alarm circuit. Alarm, you know alarm watch. So in this way, burglar alarm which are used in the jewelry shop, keeping your mind. Next application, it is used as a smoke detector. Next, LDR is used calorimetry test equipment in the laboratory. Next application, LDR is used automated rear view mirror, keeping your mind, rear view mirror, that is the automatic mirror. So this is the simple application of LDR. So in the LDR, when light is allowed to fall on the metal plate or falls on this LDR semiconducting material, a photon is absorbed by the material and electrons from valency band get excited. At that time, the electrons jump into the conduction band and hence conductivity of the material, LDR material, or resistivity of the material decreases, and therefore I can say that the electrical resistance of the LDR decreases to increase the intensity of incident light, and this is the principle of LDR. Then short definition of threshold frequency, threshold wavelength, photoelectric work function, stopping potential, and so on. So here is definition must be asked in your examination. So first I define threshold frequency. Threshold frequency, it is minimum frequency. Threshold, that is nu zero. Threshold frequency denoted by nu zero. Already you have to know nu be the frequency of light. But in case of threshold frequency denoted by nu zero, it is minimum frequency, very small frequency of incident light at which emission just begin. It is denoted by nu zero, changes from metal to metal. Threshold frequency changes from metal to metal, and it is denoted by nu zero. It is very small frequency of incident light which emission just begin. So define threshold frequency. Threshold frequency is defined as, or threshold frequency nu 0 be the threshold frequency. It is minimum frequency of incident light which emission just begin and changes from metal to metal. It's called threshold frequency. Threshold wavelength, it is maximum wavelength. So lambda denoted by wavelength, and difference between two consecutive wave is called threshold, it's called wavelength. But in case of threshold wavelength, lambda 0 denoted by threshold wavelength, and it is the maximum wavelength of incident light at which emission just begin. It is denoted by lambda 0. Then photoelectric work function, it is minimum energy of incident photon required to detach the electrons from the metal. It is denoted by W0. Keeping your mind, work function. W0 denoted by work function or photoelectric work function. So work function is minimum energy of incident photon required to detach the electrons from the metal. It is denoted by W0. W0 is the work function or photoelectric work function. Then stopping potential. It is photoelectric cell is a negative potential given to the cell at which photoelectric current becomes 0. Stopping potential is defined as the negative potential given to the cell at which photoelectric current becomes 0 is called stopping potential. So this is 4 definition is very important. Now importance formula, E equal to h nu. Here is E is the energy of photon, h is the Planck constant or Planck hypothesis, nu is the frequency of light. Then second formula, W0 equal to h nu 0 equal to hc by lambda. Here is W0 is the work function, h is the Planck constant or Planck hypothesis, nu 0 is the threshold frequency, h is the Planck constant, c is the velocity of light or speed of light. So c be the speed of light, that is equal to 3 into 10 to the power 8 meter per second, and lambda is the wavelength. Then half mv square. Half mv square equal to h in bracket nu minus nu 0. Nu is the frequency of light. Nu 0 is the threshold frequency equal to hc in bracket 1 upon lambda minus 1 upon lambda 0. The next formula, nu equal to c by lambda. Nu equal to c by lambda. Here is nu is the frequency of light, c be the speed of light, and lambda is the wavelength of light. Then 5, 1 electron volt equal to 1.6 into 10 to the power minus 19 joule. 1 electron volts value equal to 1.6 into 10 to the power minus 19 joule. Then C equal to 3 into 10 to the power 8 meter per second. And last formula, H equal to value of H, value of Planck constant or value of Planck hypothesis, H equal to 6.63 into 10 to the power minus 34 joule second. Now X-ray. Student, this X-ray is very important in your life. X-ray were discovered in the 1895 by William Röntgen, a German physicist who is the German physicist or German physics professor working in a laboratory in the Physical Institute of the University of Würzburg University. Keeping your mind, this William Röntgen is the professor of this institute, Physical Institute. He was performing experiment on discharge of electricity through gases of electric tube. They are electromagnetic radiation of very short wavelength. The short wavelength of the X-ray is 10 to the power minus 10 meter to 10 to the power minus 11 meter. X-ray are electromagnetic radiation of very short wavelength. X-ray with longer wavelength are called soft X-ray and small wavelength are called hard X-ray. An X-ray or X radiation is a penetrating power from of light energy, that is the electromagnetic radiation. X-ray were discovered in 1895 by William Remington, a German physics professor. He was performing experiments to investigate the properties of cathode rays. And student, in this way, you will read in your home. So now I stop here. Thank you very much.